folks. Welcome to my introduction to Cypress. If you have any questions during the presentations, please add them to the chat and I'll try to get back to them. I'll answer them as best as I can. I think the Zoom webinar feature actually has a Q&A section, so feel free to ask. I am Philip Jory. I'm a full stack software engineer. Have been for more than 10 years, and I've been at Albelly now for about 2 years. Today I'll be giving a brief introduction to Cypress and walking through a couple of simplified case studies with a focus on problems encountered and best practices to avoid or minimize them. Cypress also has some good documentation online, so make sure to check it out. So what is Cypress? And they have their own marketing department, and you can check out their full sell online at Cypress.io. But essentially, it's a testing framework that runs its tests from within the browser. Cypress is fast to run, easy to write tests for, well documented, and free to start with. They do operate a software as a service model, and their unique selling point is related to their parallel scheduling, which I will come back to shortly. But first, I think it's helpful to define what Cypress is not. It's not Selenium or related to Selenium. It's not a general purpose tool. It specifically runs in a single browser tab and has good connections to the application code in the browser because of this. Due to those limitations, it can't completely satisfy all the possible graphical test requirements. However, it is arguably quicker to write and run Cypress tests and make them run reliably. For example, I can remember in the old days, the automation tools that took over the mouse and clicked on specific pixel locations on the screen or took screenshots to analyze the differences between previous states. But because Cypress is well integrated with the browser, it runs fast and reliably. Meanwhile, it also offers mocks or stubs, which allow for testing in isolation. So I think it has a bit of a hybrid location in the testing pyramid, and you can cover various scenarios depending on how you use it. How much it costs may or may not be relevant to you. Although their unique selling point being the parallelization and how their licensing relates to that makes it clear what you're paying for and therefore also what you get for free. The testing framework itself and the features are the same regardless. It's simply a matter of how heavily you use it, and there are creative ways to interpret that as well, because a test recording is a full set of tests, and this could be running tests against a single microservice or anything up to an entire environment. It's really up to how you use it. I think it's worth taking a bit of a sidebar and talking about the parallelization and how it works with Cypress while we're here. Essentially some process making use of several machine instances, whether they be actual machines or in the cloud or Docker images in the cloud. They register and trigger a Cypress run, and then Cypress takes care of the scheduling. And that's their big feature, their moneymaker. That's what you're paying for. Looking at it in the Cypress dashboard, you can see the results of running some spec files in parallel against a single application and environment. We have here 21 different spec files, 124 tests spread across 6 machines, and they run in less than 2 minutes. The machines don't all start at the same time, and in this example you can see how Cypress splits the test run by spec file and schedules them as machines become available. I find it's surprisingly efficient with its distribution of the tests, and it does a good job of having the machines all finish at the same time. But can you run in parallel for free? And of course you can. The Cypress parallel scheduler can be completely bypassed, and you can schedule the individual spec files, or you could just run them all in serial on one machine. But it might not be worth it. The number of runs you get for your license is deceptively large, and you would lose out on the dashboard. And Cypress has obviously put a lot of work into their scheduling process, which I imagine would be difficult to replicate. However, it could still be useful in some scenarios. So just taking a quick look at some real-life data for this. What you see here is a Cypress dashboard for several actively developed applications in June, where we did some load testing or something similar, and in a more regular month of July. And given that the free license is 500 runs a month and the paid for license is 25,000 runs per month, we in a regular month would just barely pass that free limit. And even when we hit it hard, we still have difficulty hitting the next limit. So it's deceptive as the amount that you get. Again, more real data. This is a full year of runs against a single application that's under active development and was under more development at the beginning of the year, but 2 developers working on this. And there are unit tests. So this isn't representative of all check-ins, but it's all test runs. So again, it's just that you use less than you might expect. So now that we know what Cypress is, how it works, and what's special about it, how do you use it? So to demonstrate this, I've created an application which makes some web requests, displays some data, and then proceeded to write a few tests for it. And first up, I'm going to show you the application. So as you can see here, the application first loads all albums, and for the first 10 albums, the photos contained in these albums. Then for any other albums, it provides a button which the user can click on to load those pictures. It's nothing complicated, it's just an application that makes some deferred web requests. And we write the first test. So basic structure of the test we can see is it is our first test. We visit the albums page, and then we get the album element and assert that it should exist. We can see on the right that the Cypress runner where the steps match up, and after our final get that the album should exist, we can see the completion of web requests also in the log. So now that we've seen a simple test, let's take a look at flow of control. So Cypress supports both a asynchronous and a synchronous style. It's worth knowing that it always executes in a synchronous manner. And I have some examples which hopefully demonstrate this well. So all 3 tests here execute exactly the same way. The first test is perhaps the most obvious. It avoids all nesting and promises entirely. The second one is a little bit more random, while the third test prefers the nesting. They all have the same output, and really this is a question of your design or your style. And while one is straightforward and 3 still makes some sense, the second one is just a bit of a mess. But with a more complicated example, we can see how this could potentially add value. So in this example, which is actually for the next part of the case study, which we will see shortly, provides a nice example of some meaningful nesting. Hopefully it's obvious there are 3 parts to this test. We have the initial setup and visit of the page, where we visit the to-dos page and check that the to-do items should not exist. Then we get the to-do form input field and type the text, test text. We get the to-do add and clear button, click on it, and then assert several conditions relating to that button click. After which we return back to the main flow and continue with our test and do a similar style of check. So since I've mentioned it, the other side of this case study is another fairly simple action-based application that will record a list of to-dos. as you can see, allows the user to type text, and they can also add an item to the list and keep the text, edit it, and add it again. Finally, they have the ability to remove an item from the list, and there I wrote, and then I wrote a test for this flow. So, done. Test everything in one test. We know at the start there will be no data, and each step in the test can prepare the state for the next assertion. With some thought, we can have the application run through all its various potential states. This should look somewhat familiar to or similar to the nesting example, but without any nesting. We still visit to-dos, get that no to-dos should exist, and so on. So this is a good example of how the first scripted tests I ever wrote looked. And honestly, I would probably still write tests like this on a first pass, and maybe even leave them there if it were a particularly simple application. But what's wrong with it? It runs, it passes. I mean, that's what I expect. But we all know the maxim, expect the unexpected. So let's take another look. We can see the test is clearly testing different things without going into too much detail on the benefits of testing in isolation. Now, if we were to break the add, for example, and also break the delete, it would take 2 passes, including fixes, to figure out what exactly was broken. There's also a question of maintainability. Should we start adding assertions in here, it'll get harder and harder to read. And also being able to add a new test without risking the existing tests. So if we were to add the ability to update an existing to-do, the test would need to be sandwiched in here somewhere and could potentially cause problems for other parts of the test. The more complicated the test is, the bigger an issue this is, and things that were checked before may pass by accident and all that sort of good stuff. It sets a bad precedent for future extension because everything just goes here in this one test. With that said, I think it's worth taking a look at some of the more Cypress-specific pitfalls, partly from their documentation, and also add to the understanding of how Cypress works. And then we can come back to this test and make it the best test that it can be. So Cypress has this automatic retry for its assertions. It retries a number of times with a default timeout. First, you should always assert something because these assertions work like checkpoints, and the automatic retries, which undoubtedly are valuable, can in certain scenarios give the appearance of instability, where a test succeeds one day and fails the next because of how long a previous request may have taken. And one of the methods to moderate the retry issues is to use waiting. A little bit of a code example to explain what I mean by these retry issues and its effect on stability. So imagine back the albums application. When it first loads, it's a blank page. It then requests the albums. And for each album, requests the album photos. So there are various states in the application. In the first test, we get the albums, and then using that album, we get its related photos and check that at least one will exist. When we first get the albums, they have not been loaded, so there will be no related photos. And then the automatic retry will kick in, and as it retries from a reference to an album that did not exist when the reference was taken, it will never have related photos. If in the second example, on the right, we assert that the album should exist before checking for related photos, when the retry occurs, it will retry that the album should exist and therefore be in a position to get its related photos. It's worth mentioning that the cy wrap function in this is an older syntax, and I suspect that Cypress has solved some of these issues with the within function, which is again a reinforcement of why you should always check the documentation. Further, on these retry issues, we can see In the first example, which is a manual assertion, which is not automatically retried, that the test simply fails. The second example, however, shows that the check that the image should be visible occurs twice, once before and once after the fetches of the photos are complete. So one possible solution would be to manually wait. And in the final example, I wait for 50 milliseconds, which is enough time for the first photo to load, which leads us nicely into another pitfall, which straight from the documentation is that waiting for arbitrary times is an anti-pattern. And I think it's mainly because it introduces a minimum amount of time that the test will run for, but also that failures should be reported as quickly as possible. So there's that. And also that waiting for things that are outside the scope of the test is wasteful. And whether it should determine the pass or fail of this particular test is relevant. But Cypress also provides us with some better options. So you can, with or without mocking or stubbing any data, give a web request an alias and wait for it to be called. This has the added benefit of giving it a nice label in the test runner. Or with mock data, you can also test completely in isolation, which will also be faster and more reliable. To wrap up a couple of final thoughts on this. It's possible that wait won't work because fetch isn't supported by default, but there is a workaround that may already be included by now. And also that the retry timeout can be overridden, which might be useful in some scenarios, but it still has some potential drawbacks. It might even make sense to reduce or remove the retry to highlight issues sooner. And some other good practices from the Cypress documentation is don't use CSS classes to reference elements. These are much more likely to change and generally have a meaning in terms of style, while for clarity's sake, ideally everything should have at most a single responsibility. Testing in isolation and having tests run independently is a more general maxim for writing tests that I'm sure we've heard before. And finally, one that's a bit more vague and full of opinion, but unit integration and end-to-end tests are not the same. So regarding Cypress and where I think it fits in the testing pyramid, test the flow, test the integrations, but you don't need to test everything all of the time. So coming back to this monster of a test, we can split it out into its individual flows to start with, testing in isolation. So first, let's have a test to test the display of a to-do. So start off with mocking some test data in local storage because we need to avoid the add flow. We visit to-dos and then we check it displays correctly. And this test could also later test localization, display quirks, sorting, ordering, that sort of thing, and then be split out into separate tests further. We then have a similar test for delete after mocking some data in local storage. And we'll come back to this because it checks that a to-do element containing the correct text exists, and within the element containing that text, that there is a delete button. And clicking on it should reduce the number of to-dos to 2 and have removed the expected item. Similarly, a test for add and a test for the validation, which prevents add. And finally, with a bit of a different style, so a more complicated flow, which goes to the visit page, checks nothing exists, checks that adding and clearing will both add an item and clear the text box, and that adding more text and adding without clearing will add the expected text. With some further refactoring, we can split out some of the shared code. So first off, let's take the element selectors and just store them in an object. This allows two things. We can name the selectors nicely and we can update them from one place. Secondly, making use of the final Cypress feature that I'd like to highlight, which is the Cypress commands. These commands allow you to add a globally accessible feature to your testing framework, and they can really help to keep reuse tidy. So the likes of the elements object would have to be referenced in certain tests or included in them, while the Cypress commands are available globally within Cypress tests. Here, the go-to-to-do will accept an optional array of existing values, prepare this initial data if provided, and then resets the to-do page to show this data and visit the page. The results of this are subtle, and we can see that CY visit is replaced with CY go to do, and the selectors have, in my opinion, become more readable. But the tests are very similar. A better example, we can see here the simplification of a couple of tests, which was provided by the CY function, because the display and remove both set up test data. And that's it. We are done. We have a well-designed testing framework that should be easy to understand, easy to extend, and easy to maintain. And as the system grows, that will fluctuate, which allows me to touch briefly on another subject that's close to my heart, but is too big to cover in any real depth today. System design and design patterns that are intended to do just that. So whether it's intentional or not, systems have a design. Of course, every system has different requirements, and these problems are not simple, so each solution is unique. But there are various software methodologies to try to address these problems and help think about the final solution in a sometimes frustratingly abstract manner. They tend to boil down to things like how to separate your code and how to name things. So what I want to impress is that your testing systems are still primarily code solutions, and therefore will suffer from the same problems and same debatable solutions, which are full of macro and micro decisions. So I've gotten onto my soapbox. I've talked the talk, but can I walk the walk? Let's see how these tests hold up. If I were to implement Material UI and completely restyle the application, which means removing all the CSS class names, I know because they were custom. But let's not get cocky. I mean, when the tests fail, what sort of changes are required to fix these tests, and how obvious would it be to find them? How could we have avoided them in the first place? So restart, it looks a lot better, but the functionality is all the same. It still allows the user to add and clear the text box, to add and keep the contents of the text, and also to remove. In theory, the functionality didn't change, so the test should still pass, right? So first a bit of a cheat. The first set of tests, which were using CSS classes before, and I sort of knew a Material UI change would mean replacing them. So of course, all of these tests fail, and they fail pretty fast because it can't find anything. But what about if you're using the data selectors that are supposed to solve this problem? Do they stop this from being a problem? Not quite, but 2 out of 3 isn't bad. And even if the tests are simple, I was quite happy with this result in the end. And we will see why and what it takes to fix these issues. So first of all, it's essentially the structure of the input has changed because Material UI uses some fancy styling to wrap the input. So it actually exists in the side of the original element. Thankfully, we already created a single reference point for this previously, and the fix is quite simple. But next up, we have another structure change. And I mentioned we would come back to this because it's actually the test, which is a little bit odd. So what contains does is look up the element containing the text. And so when the item containing the text no longer also contains the remove button, the lookup will of course fail. Previously, the item which contained the text also contained the button, while now the item which contains the button contains the text in a sub-element. So changing the text to look up the first item, or the test to look up the first item and then find the button within solves the problem, removes the dependency on the location of the text relative to the button, and so would have been a better way to have written the test in the first place. And so to wrap up with some final thoughts, of course, Cypress documentation is a good place to start. The Extreme Programming Wiki page, I think, is another good place to start for the design methodologies, since I think this is where they all began. It came about with object orientation in the 90s, and even if it only gives you the sort of questions that you can ask yourself without worrying too much about what it suggests the solutions are, it can help identify what is important about even as you create something completely freeform. So in a way, design patterns are a bit like philosophy. They suggest abstract answers to abstract questions, but specific real life answers you have to find for yourself. And essentially, you're trying to create a system which you can come back to in 6 months or a year's time after working on something completely different. But also, it's a balance. The value of your time now versus the potential cost of your time later. And there are various slogans that try to embody this balance. And in general, it just means keeping things simple as possible and only creating complexity when you are doing the same thing in multiple places. You only have the level of complication that you require.